Dear students of class 12th, Assalamu alaikum. I am Mohammad Abdullah, lecturer physics, boys higher secondary school, Kupwara. So, in the last lecture, we have discussed self-inductance or simply inductance or self-induction. So, today we are going to derive the expression for the self-inductance, or we can find the self-inductance of a solenoid. As you know, this solenoid is simply an inductor. A coil which is insulated, wound in the form of a solenoid or a helical spring rather. This is known as solenoid or inductor or simply a coil. When current flows through it, a varying current flows through it, it produces varying field, varying flux, and it opposes the cause that produces it. So the growth or decay of the current is opposite, that is known as self-inductance. So for this, let us consider a solenoid or a coil. A solenoid having n number of turns. N is equal to total number of turns. Total number of turns, right? L is equal to length of the solenoid. Length of solenoid. And A is equal to area of cross section. Of the solenoid. And small m is equal to number of turns per unit length. That is, small n is equal to capital N divided by L, total number of turns per unit length, implies n is equal to NL. So total number of turns is equal to small n multiplied by L, where L is the length of the solenoid. When I is equal to current that flows through it, the solenoid produces field, that is magnetic field, inside it, which is given by जानते होंगे in the magnetic effects of current आपने field produced by a solenoid calculate किया है, पढ़ा है. So B is equal to mu naught Ni. Mu naught means it is permeability of the free space. That means there is no core material inside the coil, or it is air core inside the coil. There is no core material. N is the number of turns and I is the current. So what is total number of turns? NL. What is the field produced by the solenoid when current flows through it? That is mu naught Ni. From this we can find magnetic flux is equal to phi, which is equal to B into A, where B is magnetic field, A is the area. So area, हमने area of cross section A रखा है. What is B? It is mu naught Ni. So this is mu naught Ni into A. This is magnetic flux. So this magnetic flux gets linked with the solenoid. Now flux linked with solenoid is equal to that is, यहाँ पे हम फाई लेंगे, यहाँ पे फाई लिखने की ज़रूरत नहीं है, आप जानते हो मैग्नेटिक फ्लक्स से कंफ्यूज हो जाओगे. सो इट बी ए विच इज इक्वल टू म्यू नॉट एन आई. दिस flux gets linked with all the turns of the solenoid. Total number of turns is n, and what is the flux? That is equal to mu naught n I a. mu naught n I a. तो हम इसको मल्टीप्लाई कर लेंगे कैपिटल N से. So you will get here it is mu naught n I a multiplied by capital N, because the solenoid is having n number of turns. आपका n nl के बराबर है. So we can write here phi is equal to mu naught small n के बदले में हम डाल देंगे कैपिटल N डिवाइडेड बाय L I a into n. n और n स्क्वायर बन जाएगा. So you will get here it is mu naught n square a divided by L into I. So keeping it equation first, right? Simple सी बात है. Solenoid n is the total number of turns, L इसकी length है, a area of cross section है, small n number of turns per unit length है. So n is equal to n divided by L, or capital N is equal to small n multiplied by the length. If I flows through it, it produces field which is given by mu naught n I. मैग्नेटिक फ्लक्स बी ए के बराबर होगा. बी से मल्टीप्लाई कीजिए एरिया को तो आपका फ्लक्स, दिस फ्लक्स पासेस थ्रू एवरी टर्न ऑफ द सोलेनोइड, तो सब टर्न से मल्टीप्लाई हो जाएगा. सो दैट विल बिकम दिस mu naught n I स्मॉल n I मल्टीप्लाइड बाय n. स्मॉल n को हम कैपिटल N डिवाइडेड बाय L भी लिख सकते हैं. सो आवर एक्सप्रेशन विल बिकम दिस. बट वी नो phi is equal to Li. This is equation second. Equating first and second we get. Equating first and second we get. Equating first and second we get. यहाँ पे phi और यहाँ पे भी phi. So we can write here Li is equal to mu naught n square ai divided by L. तो यहाँ पे I और I कैंसिल हो जाएगा. So you will get here L is equal to mu naught n square a divided by L. This is the expression for the self-inductance or self-inductance of a long solenoid. So from the expression it is clear that inductance of a coil depends upon or we can say directly proportional to the number of turns. So L is directly proportional to the square of number of turns. 1 second. Directly proportional to the area of the coil. Directly proportional to area of coil. Third, inversely proportional to length of the solenoid. Fourth, it also depends upon the permeability of the core material. Permeability of core material. So अगर हम एयर कोर को रिप्लेस कर लेते हैं with a core material, so when a core of permeability mu is used, then what will happen to the expression? यहाँ पे आपका होगा is mu n square a divided by L. Mu n square a divided by L. But we know mu is equal to mu naught mu r, because mu r is equal to mu divided by mu naught. Relative permeability जिसको हम कहते हैं. So we can write here L is equal to, or L dash is equal to, L dash is equal to, it is mu naught mu r n square a divided by L, or L dash is equal to mu naught n square a divided by L, ये capital L के बराबर है, so it is mu r L. So what will happen to the solenoid when air core is replaced by a material core? Then it is self-inductance will increase. So self-inductance increases by mu r times. यानी क्या होगा? Relative permeability of the core material, the inductance increases accordingly. Right? तो हम एक दो पॉइंट्स और डिस्कस करने जा रहे हैं. When the inductors are connected in series, what will be the total inductance? एक इंडक्टर आपका है, ये दूसरा इंडक्टर है. So what will be the total inductance between A and B? मान लीजिए इसकी इंडक्टेंस L1, इसकी इंडक्टेंस L2. When they are connected in series, that means end to end, what it will be the total inductance of the combination. So you know, in series what remains the same? It is current. But in parallel combination, EMF remains the same. So in series combination, EMF is different. तो जाहिर सी बात है A और C के दरमियान एक EMF होगा, let it be E1, और C और B के दरमियान दूसरा EMF होगा, let it be E2. So we can write here this is a scalar quantity and is added algebraically. So E is equal to E1 plus E2. Right? In series combination, what remains same? Current. But potential difference is different across the different inductors, across different across different coils. So E is equal to E1 plus E2. But we know E is equal to minus L di upon dt. So we can write here minus L di upon dt, which is equal to minus L1 di upon dt minus L2 di upon dt. यहाँ पे भी I because it remains constant. The minus will get cancelled from all sides, so L and di by dt, di by dt, di by dt will get cancelled. So we will get here L is equal to L1 plus L2. So this behaves similar to the resistance connected in series, as there is also R is equal to R1 plus R2. In case of the inductors, again there is L is equal to L1 plus L2. Now similarly, we can discuss what is parallel combination. In parallel combination, you know, potential remains same, potential difference or EMF remains same, but current changes. Parallels. So now we will discuss parallel combination. In parallel combination, let us consider two inductors of inductance L1 and L2, of inductance L1 and L2, L1, L2. If I is the total current that flows, तो यहाँ पे distribution होगी, this will be I1, this will be I2, and here it will combine. So ये आपका एक point A है और ये B point है. All the inductors are connected between the 2 points. So there will be the same potential difference across each inductor. So in parallel combination, EMF remains same, but current changes. Current changes. So we can write here I is equal to I1 plus I2. I is the total current which gets distributed. I1 flows through L1 and I2 flows through L2. So total current will be I is equal to I1 plus I2. Now, according to the Faraday's law, E is equal to minus L di upon dt. Remember it. पहले हम इस इक्वेशन को डिफरेंशिएट कर लेंगे with respect to differentiating equation first with respect to t. So we will get here di divided by dt is equal to di1 divided by dt di2 divided by dt. Now from the second equation, from second we get di upon dt is equal to, it is E divided by L, लेकिन यहाँ पे माइनस होगा, E divided by L. यहाँ देखेंगे तो di1 divided by dt, it is E divided by L1. Similarly, di1 divided by dt आपका होगा minus E, because E remains same, divided by L1. di2 divided by dt will become minus E divided by L2. So using in this equation, we get E divided by L is equal to minus E divided by L1 minus E divided by L2. Negative sign will get cancelled, so you will get here E by L is equal to minus E divided by L1 plus E divided by L2. E cancel हो जाएगा, so we will get here 1 by L is equal to 1 by L1 plus 1 by L2, or 1 by L is equal to L1 plus L2 divided by L1 L2, or L is equal to L1 L2 divided by L1 plus L2. So this is the total inductance in case of a parallel combination. Similarly, we have to find what is the energy stored by the inductor. Energy stored by the inductor. जैसे कि आपने पढ़ा है energy stored by the capacitor, इसी तरह से हम यहाँ पे energy stored by the inductor भी कैलकुलेट कर लेंगे. यह आपका बोर्ड क्वेश्चन नहीं है, बट कभी किसी कॉम्पिटिटिव एग्जाम में इसके रिलेटेड कोई न्यूमेरिकल हो So for this, let us consider an inductor. Which is connected to a source of EMF. Which follows the current through it. Let current that flows through it is equal to I. Induced EMF produced is equal to minus L di divided by dt. और यहाँ पे एक स्विच भी हम डाल देते हैं, that is K, ये माइनस और ये प्लस. This is applied EMF. V is the potential difference. V is equal to the potential difference applied. So here we have to find the expression for the energy stored by the इंडक्टर. ज़्यादा डिटेल्स में मैं नहीं जाऊंगा, सिर्फ मैथमेटिकल एक्सप्रेशन यहाँ पे डिराइव होगी. So let I is equal to current that flows through it. Then induced EMF. Induced EMF is equal to, ये आपका E होगा, which is equal to minus L di divided by dt. Right? As you know, this opposes the cause. It opposes the cause. So in order to maintain the current, what we have to do? External work done. External work done here is done by battery or a source of EMF. So in order to maintain the current, external EMF is applied, right? when external EMF is applied, that must be at least equal to induced EMF. At least equal to induced EMF, right? So we can write here E is equal to minus V, where V is the applied EMF or potential difference. तो दोनों को यहाँ पे E के बदले में V डाल देंगे, so we will get here V is equal to L di divided by dt. Now V is equal to dW divided by dQ is equal to V, work done per unit charge. जो आपने अपने इलेक्ट्रोस्टैटिक्स में पढ़ा है, वर्क डन पर यूनिट चार्ज, W is equal to QV और V is equal to W divided by Q naught. So we will write here dW divided by dQ is equal to L di divided by dt. dW is equal to L into di divided by dt into dq, right? dW is equal to L into di into dq upon dt. Again dq divided by dt is current, so dW is equal to Li di. So we have to find the total work done. Total work done when current attains maximum value, that is I naught. So we can write W is equal to integral of dW, which is equal to integral of Li di from 0 to I naught. So we can write here W is equal to L constant है, so integration of I di from 0 to I naught. I की integration I square by 2, so it will become L into I square divided by 2 from 0 to I naught. W is equal to L into I naught square divided by 2 minus 0 square divided by 2, using the limits. So we will get here W is equal to 1/2 of Li naught square. So this is total work done. Since work done is equal to energy stored, so we can write here U is equal to 1/2 of Li naught square. This is the energy stored by the inductor. Now, point is, this energy is stored by the inductor in magnetic field. Remember this. In case of the capacitor, the energy is stored by the capacitor in electric field, but here in the magnetic field. Now we can write it as Um is equal to 1/2 of L I naught square. So this is magnetic energy, but our coil is similar to that of the solenoid. Similar to that of the solenoid. So for a solenoid, we can write here B is equal to mu naught N I naught, because magnetic field is equal to mu naught N I. यहाँ से हम I naught का वैल्यू कैलकुलेट करेंगे, so you will get here B divided by mu naught N. So आप इस एक्सप्रेशन में डाल दीजिए, you will get here Um is equal to, L का भी आप वैल्यू जानते हो, L किसके बराबर है, mu naught N स्क्वायर A डिवाइडेड बाय N स्क्वायर AL डिवाइडेड बाय L. So we can write here, this is 1/2 of L के बदले में डाल देंगे हम, L के लिए आपके पास रिलेशन है जो इससे पहले हमने डिराइव की है. It is mu naught, it is N square, it is A divided by L, right? तो आपका स्मॉल n होता है कैपिटल N डिवाइडेड बाय L, कैपिटल N डिवाइडेड बाय L, और we can write here capital N is equal to NL. Capital L is equal to NL. तो आप ध्यान दीजिए, यही आपका L होगा यहाँ पे म्यू नॉट, ये N स्क्वायर L स्क्वायर A डिवाइडेड बाय स्मॉल l. एक L हमारा कैंसल हो जाएगा. So we will get here L is equal to mu naught N square L A, right? तो हम यहाँ पे डाल देंगे L के बदले में, it is mu naught is N square L A, right, into हम I naught के बदले में डाल देंगे, ये आपका B स्क्वायर होगा, B स्क्वायर डिवाइडेड बाय, क्योंकि I naught का स्क्वायर है, यहाँ पे म्यू नॉट स्क्वायर होगा और यहाँ पे N स्क्वायर होगा. हाँ, इसको कैलकुलेट कीजिए, N स्क्वायर और N स्क्वायर कैंसल हो जाएगा, राइट? एक म्यू नॉट और एक म्यू नॉट भी कैंसल हो जाएगा. सो वी विल गेट हियर Um इज इक्वल टू 1/2 को साथ लीजिए, N स्क्वायर कैंसल हो गया, सो इट इज B स्क्वायर AL, it is B square AL, where A is area of cross section, L is the length of the coil or length of the solenoid, divided by, यहाँ पे एक म्यू नॉट बचेगा, ये N स्क्वायर कैंसल हो जाएगा, that is म्यू नॉट, right? Now volume is equal to area multiplied by length, that is V is equal to AL. So we can find here energy density. We can find here energy density. Energy density आपकी होगी UM बार. जैसे हम एनर्जी डेंसिटी कैपेसिटर्स में कैलकुलेट करते हैं. So UM bar is equal to UM divided by V, which is equal to UM किसके बराबर है? 1/2 of B square AL divided by mu naught multiplied by 1 upon V, where V is not velocity, it is volume. Volume is equal to AL. So UM bar is equal to 1/2 of B square AL divided by mu naught multiplied by 1 upon AL. AL और AL cancel होगा, so UM bar is equal to, it is B square divided by twice mu naught. So this gives the energy density of solenoid or a coil, right? This is analogous or similar to UE bar भी हमने calculate किया है in capacitors में 1/2 of epsilon naught E square. वहाँ permeability of the free space, यहाँ permittivity of the free space, यहाँ permeability of the free space. This is magnetic field and this is electric field. So this was total regarding the energy stored by a capacitor. So inshallah in the next lecture we will discuss AC generator. Okay.